In this video, we're going to be looking at factorising and expanding equations and expressions. At first, we'll start with a single number over a set of brackets, and next we'll look at expanding and simplifying expressions with more than one set of brackets. Finally, we'll look at factorising expressions by taking out the highest common factors and taking it into brackets. Here we're trying to expand a single set of brackets, which is 7 brackets 4x plus 6. Remember that the operation between a number and the symbol will be multiplication, unless we are told differently. So we multiply 7 by whatever's inside the brackets. So we'll do 7 times 4x will give us 28x, and then 7 times 6 will give us plus 42. In the next problem, we have 2 sets of brackets which are separated by subtraction, and we're being asked to expand the brackets and simplify the expression. First, we'll expand the brackets, then combine the like terms to simplify it. So we already know that this one's going to be 28x plus 42. The second one's got a negative coefficient outside it, so it's negative 3 times 7x, which will give us negative 21x, and negative 3 times positive 9, which will give us negative 27. Now we have 2 lots of x's here. We can combine those together. 28x take away 21x, which would give us 7x, and 42 take away 27, which would give us 15. And it's still positive 15, so we write it as 7x plus 15. Here you can see a range of problems for you to attempt. So if you pause the video now, attempt the problems, and I'll come back and talk through the answers for you after you press play. So in problem number 1, we've got 5 outside of the brackets and x plus 4 inside. So we're going to do 5 times x gives us 5x, and 5 times positive 4 gives us plus 20. So the answer would be 5x plus 20. On the next one, we've got 5 outside of a set of brackets and 2m minus 3 inside the brackets. Again, you're going to multiply the term outside by each of the terms inside. 5 times 2m will give you 10m, and 5 times negative 3, positive times a negative, gives you a negative 15. So 10m negative 15, or minus 15 would be the answer. In question number 3, we've got a negative number outside of the brackets. So negative 9 times the first term, which is 2w, is going to be negative 18w, a negative times a positive. And then we've got negative 9 times negative 4. Negative times a negative gives a positive. Well, 9 times 4 is 36, and it's going to be positive 36. So we have negative 18w plus 36. Now in question number 4 shows you that it doesn't actually need to be a number outside of the brackets. So here we've got x outside the brackets, and then inside y plus 2. Again, we're going to multiply the term outside by the terms inside. X times y would give you xy, and x times 2 would give you plus 2x. So the answer would be xy plus 2x. So for question number 5, we've got 3a outside of the brackets, and then 2b plus 7 inside the brackets. Now remember, when we're multiplying 2 terms together, we can multiply the numbers together. So 3 times 2 would give you 6, and then a times b would give you ab. We're multiplying a times b, so we can put them together because we assume that multiplication is in the middle of them. So we end up with 6ab. Now we need to multiply 3a by the other term that's in the brackets, which is 7. So 3a times positive 7 is going to give us positive 21a. So you can write the answer 6ab plus 21a. In the next one, we've got x outside the brackets and inside the brackets, plus 5. Let's see how this affects it. So we've got x times x, which will give us x squared. And then we have x times positive 5, which would give us positive 5x. So you can write the answer x squared plus 5x. So in number 7, we've got b squared outside the brackets multiplied by b plus 3 inside the brackets. Now, let's remember our index laws. When you have 2 numbers and they're being multiplied together, and they're both the same, in this case b, but they have different powers, we can add the powers together. So b squared times b to the power of 1 equals b to the power of 3. So that's what we can write as the product of our first multiplication, b to the power of 3. We've then got b squared times positive 3, so that gives us plus 3b squared. So you can write your answer b cubed, b to the power of 3, plus 3b squared. In the next one, we've got another power as well. C to the power of 2, brackets, c plus a. c to the power of 2 times c would give us c to the power of 3. Remember, The c inside the brackets has a power of 1, we just don't write it. C to the power of 2, or c squared, times a would give us positive ac squared. So we can write this as c cubed plus ac squared. And finally, we have two sets of brackets. So here we're going to expand the brackets and then simplify all the like terms together. So the result from our first set of brackets is going to be 3a plus ac, and the result from our second set of brackets is going to be ac plus 2c. So here we've got two lots of ac that we can combine together. We haven't got any other single a's and we haven't got any other single c's, so those terms will remain the same. And we end up with 3a plus 2ac plus 2c. So that gives us all the answers to the problems. Before we go further into looking at factorising, let's just remind ourselves how to find the factors of numbers. For example, 48 and 56. And then how to establish the common factors and then the highest common factor of 48 and 56. So here we've got 48, and we'll start off with 1 times 48, 2 times 24, 3 times 16, 4 times 12, and 6 times 8. And we know that 7 doesn't go into 48. Now, because I've got to 8 on the right-hand side, I know I don't have to search for any more factors. We can do the same thing for 56. We've got 1 times 56, 2 times 28, 4 times 14, and 7 times 8. And we know we've got all our factors there. Now, what factors do they share? What are common to both numbers? 1, 2, 4, and 8. And as 8's the largest number, 8 is going to be the highest common factor that we would use. At this stage, we're looking to factorise each of these expressions into brackets. There is a clue here in the question because they ask you to only factorise, meaning there's only one highest common factor between the terms. If you have a look at the last question, it asks you to factorise fully or completely, meaning there's more than one highest common factor between the terms, and we'll look at how we get those. Let's start with this one, 28x plus 24. What's the highest common factor between 28 and 24? And the answer would be 4. So we'll put that outside of a set of brackets. Now we need to divide each of these terms by 4 to find out what goes inside the brackets. 28 divided by 4 would give 7. 28x divided by 4 would just give 7x. So we'll write that here. Then we've got positive 24 divided by 4 would give you positive 6. And we can write that next. So the answer is going to be 4 brackets 7x plus 6 close brackets. Now in the next one, you can see that it doesn't necessarily need to be a number that's a common factor. Here we've got x's in both of them. We've got x squared plus 4x. There's an x in both of them. In the first one, we've got x times x. So we're going to take x as a single power outside of the brackets. And then what will be multiplied by that to get x squared? Well, we'd multiply it by x. So we'll write that inside the bracket as well. What will we multiply by x to get 4x? Well, obviously it'd be 4. Is it positive? Yes, it is. It's in the actual expression in the original one. So we put x brackets x plus 4 close brackets. Now in the last one, we've got 18x squared plus 9x. Something very interesting happens here, because two things. We've got, first of all, we're being asked to factorise fully or completely. This gives us a clue that there's more than one factor in each of these terms that's common. And also, we'll look at how we deal with the fact that the highest common factor is a whole of the term. Okay, so what's the common number between 18 and 9? Well, the highest common factor there is going to be 9, so we'll take that outside. And we've also got an x squared and an x. Because we've got an x in both of those terms, we're going to take that outside of a set of brackets as well. So we've got 9x, and then we open a set of brackets. What are we going to multiply by that to get 18x squared? Well, we're going to multiply the 9 by 2, and we're going to multiply the x by x to get x squared. So inside the brackets, we've got 2x. Now, what are we going to multiply by 9x to get 9x? And the answer is quite simple. It's 1. So we'll put plus 1 inside the brackets as well. So you end up with 9x brackets 2x plus 1 close brackets. It's really important, even though 9x is the highest common factor, but it's also the term, there has to be a term inside the brackets to create that 9x in the original expression. So that's the answer for this one. Once again, here you'll find a range of problems to attempt, so pause the video here and I'll review the answers when you press play again. So for question number 1, the highest common factor between 9y and 12 is going to be 3. And there's no difference with that being a negative 12 either. So we're going to put 3 outside of a set of brackets and then consider what we'd multiply by that to get 9y, which would be 3y, and what we'd multiply by 3 to get negative 12, which would be negative 4. Negative times a positive creates a negative. So the answer for that one would be 3 brackets 3y minus 4 close brackets. In the next one, the common factor between 6x and negative 18y is going to be 6. So we'll take that outside of a set of brackets. In order to get the 6x in the original expression, we'd have to times it by x, so that would be the first term in our brackets. And in order to get negative 18y, well, negative 3 times 6 would give negative 18. So we'll put negative 3 and y, because negative 3y times 6 would give us negative 18y. In the next one, there's not a number that's common to both terms, it's a letter or a variable. So in both cases, both terms have an x, so we're going to put that outside of a set of brackets. And then inside, we'd have x, because x times x gives us x squared, and then plus 5, because 5 times x gives us positive 5x. Now in all of those problems, they asked you to factorise, which meant there was one highest factor in both of those terms. Here they're saying factorise fully or completely. This means that there's more than one factor in both terms. Here, in question number 4, we've got 30x squared minus 4x. So let's think of the numbers first. What's the highest common number that goes into both 4 and 30? And that would be 2. And we can see they both have x's in them. So we can take 2x and put it outside of a set of brackets. What am I going to times by 2 to get 30? Well, it'd be 15. And what would I times by x to get x squared would be x. So we'll put 15x inside the brackets. We can double check that as well, which is always quite a good thing to do. 2x times 15x would give us 30x squared. Great. Now for the next term, what would we times by 2x to get negative 4x? Well, I'd have to times it by a negative, so it's going to be a negative 2. And we'll put that as the second term inside the brackets. In the next one, we've got 5a squared minus 15a. So we can see that numerically, we've got 5s is the highest common factor that goes into both of those. And we've also got an a in both of them. So we can take 5a outside of the brackets. Now what would I times by that to get 5a squared? Well, it would simply be a. The coefficient of that is 1, but we don't tend to write it. What would I times by 5a to get negative 15a? Well, what would I times by 5 to get negative 15 would be minus 3. And I don't need to times anything by the a, because there's only the single power of a in the actual expression to start with. Now in this last one, we've got quite a lot of information here. So we've got 4a squared bc plus 6ab squared c plus 18abc squared. Now you can see numerically that the highest common factor for all of those is going to be 2, because that goes into all of the numbers. You can also see that each of the terms also has an a, b and a c in them. So we can take one of each of those terms and put them outside of the brackets. So we've got outside as our common factor is 2abc. Now I need to consider first, the first term inside the bracket is going to be, what am I going to multiply that to get 4a squared bc? Well, I don't have to worry about the bc because that's already there in the factor outside. I need to think, what am I going to multiply the 2 by to get 4? That would be 2. And what would I multiply the a by to get a squared? So 2a. So for the next one, we can do the same process. What am I going to multiply the number by to get 6? Which would be 3. Let's just double check. It is positive, so it's going to be positive 3. And then what would I times the b by to get b squared? And of course, that would be b. So we'll put 3b here. Lastly, what would I multiply the 2 by to get 18 would be 9. And what would I multiply the c by to get c squared would be 9c. So we end up with 2abc brackets 2a plus 3b plus 9c. So that's the answers for these problems. Over the course of this video, we've looked at how to expand a set of brackets by a number outside the brackets and with more than one set of brackets. Then we looked at how to factorise expressions by taking out the highest common factor or factors. In the next video, we'll be looking at linear equations and how to calculate the value of y for a range of the values of x. I'll see you then.